Hello everyone, welcome to the channel No Engineering. I am Godso. Today we're going to be talking about resistors. We're going to have a look at what they are, the various types, their operation, and their usage. If you don't want to miss this for anything, please sit down, subscribe if you haven't done so. Let's dive in. A resistor is a passive electrical component that is usually used to limit or regulate the flow of electrical current in an electronic system. It is a passive component because it cannot produce electrical energy on its own. Rather, it receives it from other sources and either dissipates or absorbs it. These are some photos of resistors and also the generally accepted symbols for resistors. In this video, we'll be looking at the two main types of resistors, the fixed resistors and variable resistors. We'll also go a step further to look at other special resistors such as the light dependent resistors, thermistors, and varistors. Fixed resistors. These are the most widely used type of resistors. Their resistance values are determined during the manufacturing and remain the same thereafter, even if it is used in a circuit. Below shows a picture and some symbols of a fixed resistor. Some examples of fixed resistors are carbon resistors, wire wound resistors, metal oxide film resistors, and metal film resistors. Variable resistors. These resistors are given default resistance value during production, but has additional features that permit us to vary the resistance value. Some examples of variable resistors are resistor box, rheostat, rotary potentiometer, and sliding potentiometers. Looking at other special resistors, we have the light dependent resistors, also referred to as photoresistors. Its resistance values varies with a change in light intensity. Thermistors, as the name indicates, are heat sensitive. Their resistance values vary with a change in temperature. And varistors, the resistance of these resistors vary with a change in the applied voltage. Some resistors don't have their resistance values on them. Instead, they have bands of colors on them. Each color at the various bands are manipulated in a special way to find the resistance value. As indicated in the table shown, the first and second band represent the first and second digits respectively. The third band represents the multiplier, and the fourth band represents the tolerance. Considering the resistor shown, the first band is blue, 6, the second band red, 2, the third band black, 0, meaning times 10 power 0, which is 1, and the fourth band is gold, which is a tolerance of 5%. Meaning the resistance of our resistor has a first digit of 6, second digit of 2, multiplied by 1, and a tolerance of plus or minus 5%, giving us 62 ohms plus or minus 5% tolerance. Operation of resistors. In order to really understand the operation of resistors, we have to introduce other quantities such as voltage and current. And let's visualize the whole picture as water flowing through a pipe with an obstruction preventing the free flow of water. In this diagram, where we compare water circuit and electric circuit, helps us to appreciate it more. Here, the water pump representing the source voltage, the water current representing the electric current, and the obstruction representing resistance. The relation between these three quantities is described by George Ohms of Germany as V is equal to IR. Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points, provided the temperature remains constant. Factors that affect the value of resistance: type of material, length of resistor, thickness or area of the resistor, and temperature of the conductor. To appreciate this better, we consider the rod with length L, area A, and resistivity ρ, and we are saying R is equal to ρ L over A. From the relation, the resistance R is directly proportional to the resistivity ρ and the length L, but inversely proportional to the area A. The resistivity may vary for different materials. That is why the type of material is considered a factor that affects resistance value. Observing the graph carefully, it is observed that resistance is directly proportional to temperature. That is why Ohm's law insists on constant temperature for accuracy. So what steady resistors? Do they have any uses at all? Of course yes, they have so many uses, but then we shall look at a very few important ones. Resistors are used to reduce the flow of current in circuits. Resistors are used to adjust signals in amplifiers. Resistors are used to divide voltages. Resistors are used to bias active elements, and so many others. Thanks for watching this video. Of course, it wasn't like our normal regular videos, it was more or less like a lecture, but I believe you enjoyed it. If you haven't subscribed, please consider subscribing and share. As always, stay positive. Bye.